Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 10 in our incredible new tutorial series where you're unleashing the power of your Raspberry Pi Pico W. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we will be using the Sunfounder Kepler kit for the Raspberry Pi Pico W. Good news is this includes all the gear that you will need for this entire class, and it also includes the Pico W itself, so everything that you need. Now, I realize most of you guys probably already have your kit, but if you don't have your kit yet, look down in the description. There is a link over to Amazon. You can hop over there and pick your gear up, and believe me, your life and my life are going to be a whole lot easier if we are working on identical hardware. But enough of this shameless self-promotion. Let's talk about what I am going to teach you today. And what I'm going to do is I'm going to show you my solution to the homework assignment that I gave you in lesson number 9. First of all, how many of you guys were successful in doing the homework? If you were successful, leave a comment down below. I am legend, double chest bump. And if you were not, leave a comment down below. I folded up like a cheap Walmart lawn chair. But never fear, I'm going to show you the solution today. And really, it was pretty straightforward because the code is very similar to the code that we developed in lesson number 9. You're just taking that and you're connecting up an LED. So let's get started by coming over here and showing you the schematic, that I did for this build. And so I will need to hop out of your way here. I'll need to get out of your way. And then what you can see is it's a pretty simple build. I am using the physical pin 21, which is GPIO pin 16. I put the long leg of the LED right in that pin, and then the short leg connects to a 220 ohm resistor, which comes over here and then connects down to the ground rail. Over here on the third pin on the Raspberry Pi, I create the ground rail. And even though I'm not using it, I just kind of as a matter of habit created a power rail, even though we're not going to need it in this particular build. Okay, so we went ahead and I have built that, and let's see where that view is. Let me turn that other thing off. You don't want to see that. Okay, so that looks good. Now this is what you can see the build is, and so you can see that I create my ground rail here, I create my power rail here, long leg of the LED is then connected to physical pin 21, which is GPIO pin 16, short leg goes to one leg of the 220 ohm resistor, other leg of the 220 ohm resistor is connected back to the ground rail. So we have a pretty simple build there. And so now what we just need to do is we need to come in and we need to program this thing up. And so let's come over here and let's fire up Thonny. And now let's see if we can come in here and if we can get this thing programmed up. Okay, well, what is the first thing? Well, we need to import our library. So from machine, we need to import, we're going to be doing PWM, so need to import that method. And we're going to be working with the GPIO pin, so we're going to import pin. Now I always just like to from time import sleep, because it seems like usually we end up needing a delay in here. Now, what was I connected to? My out pin was physical pin 21, which is GPIO pin 16. Now I need to create my PWM object, my analog out object. And so I'm going to call that object analog out. You can call yours whatever you want, but it is a PWM. We're going to create a PWM channel, and it's going to be connected to pin what? Out pin, which I just set up. Okay, so I set up out pin, and then I'm telling it the pin that I'm using is out pin, and I'm telling it I want that to be a PWM pin. Now we need to go ahead and give this a frequency to run at, so I am going to say analog out dot frequency, and we saw last time 1000 hertz is a pretty useful frequency to do. And then I'm going to go ahead and turn it off to begin with. So I'm going to say analog out the duty cycle, which is an unsigned int at 16 bits, and I'm going to set the duty cycle to 0, which means in that 1000 hertz, if it's operating at 1000 hertz, one cycle is 0.001 seconds, 1 millisecond. Out of that millisecond, it is on 0 of the time. Okay, it is on 0 of the time, if that makes sense. Okay, now what I'm going to do is I'm going to go ahead and set up a while loop. So I'm going to say while true. When is true? True. True is always true. So this is going to be an infinite loop. And now I'm going to get from the user the voltage. So I'm going to say my voltage is equal to, remember it always inputs as a string, so I want to change it to a number, so I'm going to float it to a floating point number, float the input, and then the input string is what output voltage do you want? What output voltage do? I'm having a trouble with my keyboard today. What output voltage do you want? Sometimes I go a little bit too fast. Question mark space, and then close the string, close the input, and close the float. Okay, now this is going to give me a number between 0 and 3.3. But, okay, but the duty cycle that it wants is a 16-bit int, and that is a number between 0 and 65,550. So I've got to take that 0 to 3.3 number, and I've got to change it into a 0 to 65,550. And so I am going to need to do a little what? I am going to need to do a little math. And this kind of math we sort of went through last week, but this is so important. I really want you guys to get comfortable with doing these linear equations. Okay, so if I input that I want 0 volts, what PWM signal would I want? 0. I want it off all the time. Now, if I say that I want 3.3 volts, which is the maximum, then if I say I want 3.3 volts, which is the maximum, then what PWM signal do I want? I want 65,550. Okay, so now this is my point 1. This is my point 2. If I have 2 points, I can create a what? A line. And we remember at point 1, this is x1 and y1. This is x2 and y2. First step in creating a line is to find the slope. So m is always equal to y2 minus y1 over x2 minus x1, and it sure makes the math easy when one of the points is 0, 0, so this is going to be y2, which is 65,550 minus 0, and then that's going to be over x2, which is 3.3 minus 0, and then this whole thing becomes m is equal to 65,550 divided by 3.3. So how cool is that? Now the equation of the line is y minus y1 is equal to m onto x minus x1. All right, so y minus y1 is what? y1 is 0, that's nice, is equal to 65,550 65,550 divided by 3.3 times x minus 0. And so this whole thing becomes very simply y is equal to 65,550 divided by 3.3 times x. Now let's go in and let's sort of put in what our values are. Now what are we getting from the user? We are getting x, but what are we calling x? We are calling that my voltage, right? And so this is going to be 65,550 divided by 3.3 times my voltage, like that, and that's equal to y. Well, y is what I am turning the 0 to 3.3, and that is what? That is my PWM val. And so what I'm going to have is PWM val is equal to 65,550 divided by 3.3 times my voltage. And now we can go back. You'll keep this in front of you, okay, because that's what we're going to need to program in now. So let's come back over to our code view here, and let's put that equation in. Because remember, I don't apply to that PWM pin, I don't apply my voltage. What do I apply? The PWM val, which we just figured out how to calculate. So PWM val is equal to 65,550 divided by 3.3, okay? And then times what? Times my voltage, like that, okay? That looks good. And now what do I need to do? Now I need to apply that PWM val. So what was my analog out object? It was analog out. And then what am I going? Ooh, I have a mistake up here. Doesn't count if you catch it before you run it the first time. Do T analog out dot do T. And it is an unsigned 16-bit int. And then you got to remember up here, the 6550 divided by 33.3, that's going to create some floating point number. But the input here needs to be an integer. So we're going to take the int of the integer value of PWM val, which we just calculated, close the int, and then close the analog out. And what this int just does is it would turn like 65,350.467. It would round it off to an integer, okay? And that is what is needed. I don't think that I actually need a sleep here. I don't actually think that I need a sleep because I don't need a sleep because actually it's going to come back and then ask for the voltage again, if that makes sense. Okay, I'm going to need everyone to hold their breath on this one. And it ran, at least. It didn't make an error. And so let's come down here and let's get ready to put an input on. But what I want to do is I want to come over here. Where is a good view? I want to come to here. And then let's see if I can turn this back on. Trying to get something cool here for you to see. Okay, yeah, so now what you can see is you can see the code view and you can see the LED. And so now let's just say that, let me get a little bit further out of your way so you can see what I type in here. Let's see if that works. Okay, now what I'm going to do is I'm going to put in a value of, let's say, 3.3. So this should be full brightness. So what are we hoping? We are hoping that this LED turns on full bright. And hold your breath. Giddy up! Do you see that? Full brightness on the LED. That is pretty darn exciting. Ooh, but it's not full brightness because what did I do? I was thinking that is not full brightness. What is my mistake? I accidentally typed in 33.3 up here. So that is really kind of dim, and so I'm going to take that back to 3.3. We are going to run the program again, and this time I'm going to say, what voltage do I want? 3.3. And then this time, boom, indeed that is full brightness. Well, what if we said 1.65? Okay, noticeably dimmer there. What if we said 0.8? And that is noticeably dimmer. Half of that would be 0.4, and then 0.2, and then 0.1, and then 0.05, and then 0.025, and then 0.01. Do you see, even at like, that's a 100th of a volt. At a 100th of a volt, what we're still seeing is we're seeing something very, very dim. And then if we go down to 0.001, like 0.001, it's still, I can barely see it. Let's try 0.0001, like that. And now it's off. Or of course, if we just put in 0, it's going to be off like that. But let's come back and let's put it 1.65. And guys, I want to go in and I want to talk to you a little bit more about the PWM, because when I watched last week's lesson, I'm not sure if I really kind of gave you all the details that you needed. So I think it'd be good if we went over that part of it again. And so what I will do is I will come in over here. Let's see. I'll come in. I'll come in here. And then I will turn this one off, and then I will scoot it over. Okay, so what I want to do is I want to come in and I want to see if we can look at that PWM signal. So what you can see is I've got the little probe tip from the oscilloscope, and I'm going to come in and I'm going to put that in the, I'm going to readjust this just a little bit because I want to make sure that I don't short out on a different pin. And so now what I'm going to do is I'm going to come in and I'm going to put this in that physical pin 21, which is the GPIO pin 16. And then I need to also connect up the oscilloscope ground. I put the wrong one. This is the oscilloscope pin. Okay, this is the positive, so I'm going to put that in like that, and now I need to connect this other one up to the ground rail, which is right there. Okay, and so I think I've got that now pretty darn good in there. Okay, so now you can see that. Now let's go back over here, and what did I put in? What did I put in for my voltage? 1.65, which is half of 3.3. So for PWM, you would expect the signal to be high for how much of the duty cycle, how much of the overall cycle. You would expect it to be high for half. And boom, look at that. So now when we come over here, let's go through some of this. What you can see is we come up to 3.3 volts. And then what is our frequency? Our frequency is 1000 hertz. Why is our frequency 1000 hertz? Because we set that right up here to 1000 hertz. Does that make sense? And then what is my, I do need to get a little further out. What is my duty cycle? My duty cycle is 1 millisecond. My duty cycle is 1 millisecond. That means from the time you start the cycle, your up part and your down part, that is 1 millisecond. Now the cool thing is with these modern oscilloscopes, it calculates that for you. But if you wanted to see that yourself, you would come down here and it says in the horizontal, each division is 200 microseconds. 200 microseconds is 0.2 milliseconds. So what is one cycle? Well, let's see. Each division is 0.2 milliseconds. So we start at 0. This is 0.2, 0.4, 0.6, 0.8, 1 millisecond. So you see, we can read it off of there. And similarly, if we wanted to calculate the frequency, 1 millisecond is 0.001 second. Put it in your calculator. 1 divided by 0.001 seconds is what? A frequency of 1 kilohertz or 1,000 hertz. Does that make sense? Okay. So let's say that we wanted to go to about half of that. So what I'm going to do is I'm going to come back over here, and then we're going to put in that I want this instead of 1.6, I want it 0.825 like that. And that should be about a quarter of a cycle. So we go there, and then we come back over here to this view. And now what do I see? As expected, the duty cycle is 25%. So it means that for one entire cycle, it is up for a quarter of a time and it's down for a quarter of a time. The cycle is still 1 millisecond and the frequency is still 1,000 hertz or 1 kilohertz. Okay, what I want you to see is as you change the duty cycle, that's just changing how long it stays up. It is not changing the overall cycle. So let's come back over here. And so what I'll do is instead of 0.825, I will put 1.65. And boom, what you see is the cycle did not change. The cycle time did not change. It just changed what fraction of that cycle time it stays up. And so let's say 0.25 volts. You can see the cycle stays the same, but it just changed what fraction of the time it stayed up. And the fraction of time that it stays up is called the duty cycle. And now you can see that we're down to about 7%. Okay, tell me something that would be interesting for us to change here. What if we came in and instead of saying 1,000 hertz or 1,000 cycles in a second, we could set that to 100, okay? Now I set that to 100, and let's run this again, okay? And then again, what output voltage you want, I'll set it to 1.65, like that, and then enter, and then wow, let's see what happens. I'm going to have to adjust this trigger a little bit. Let me see if I can get here and see. Okay, that looks good, and then I'm going to need to move this down some. It kind of auto-cycled everything. Okay, and now I'm just going to expand this a little bit. Okay, now what you see is at 1.65, what is still true? It is on for half the time. And so the duty cycle is 50%, as you would expect. But what has changed? The change is the frequency is changed to 100 hertz. Now, how do we know that? Let's come down here, and now we see each division is 2 milliseconds. So if we start at 0, this is 2, 4, 6, 8, 10 milliseconds. What is the cycle? 10 milliseconds. 10 milliseconds is 0.01 seconds. What would the frequency be? 1 over the cycle. So 1 divided by 0.01 is what? 100 hertz. What has changed here? When we went to 100 hertz, we're operating slower. And as we operate slower, we're getting to that point that you can almost perceive a little bit of a blink there. You can almost perceive a little bit of a blink. So you can see why I like to go at 1,000 hertz, because it really is so fast you can't see any of that. What if we came over here? What if we came over here? And what if we went to 10 hertz? Tell me what you expect to happen when I go to 10 hertz. Okay, so let's run this again. Okay, and I'm going to do 1.65, which would be about a 50% duty cycle. And when we come over here now to the LED, what do you see? You distinctly see a blink. Now let's see if I can get this back. Sometimes these are kind of hard to adjust in real time. Let's see. Okay, that's almost there. Let's see if we can cycle it like that. Okay, and then I'll move this. Okay, I'm trying to get it to trigger. Okay, see if I can. It's having a little bit of trouble triggering on this 10 Hertz signal. Okay, that is looking pretty good. Let's see if I can adjust it. I'm not going to sit and fool with this too much longer if I don't get it like I want it. You see, it's going so slow, it's not real easy to trigger. Okay, there, I've almost got it. Let me see if I can move it over. It keeps auto-scaling back. I'm not going to fool with it anymore. But what I will show you is what matters. If I could really look over it and see all my settings, I could get it working. But what do we see here? We see now that we have a frequency of 10 Hertz. That is a cycle of 100 milliseconds, which means each cycle is 1/10 of a second. So you can actually kind of see that. And that is probably why the scope is having trouble actually syncing to that very well. And then what you can also see, if I get further out of your way, you can see that we've got the duty cycle of 50 Hertz. But why would we certainly not want that? You can certainly see a very distinct blinking here. And so what we really know is where we started. What we really know is that something like 1,000 Hertz, 1,000 Hertz is really where you want to go. We'll run that. And then I'll say I want 1.65 volts. Okay. And then we'll come over here. I'm going to actually try to get this thing to sync correctly now. 1,000 Hertz. This oscilloscope is giving me a little bit of trouble today. Okay, there it is. And now I'll step this up. Okay, I'll bring it down. And now I will scoot it over. Okay, and so now we're back to where we were to begin. Oscilloscope is working correctly. So we are at a frequency of 1 kilohertz, that's 1,000 Hertz. Our cycle is 1 milliseconds, which we would expect, and our duty cycle is 50%. So hopefully that all makes sense. Guys, I hope you are enjoying taking these lessons as much as I am making them. If you enjoyed this lesson, make sure to give us a thumbs up. And then I need to give you guys a homework assignment. I need to give you guys a homework assignment for next week. And what your homework assignment is for next week, your homework assignment is to come in now, and instead of getting input from the user on what you want the voltage to be, I want you to get the input from a potentiometer. And so that potentiometer is going to go down into your circuit. If the potentiometer is all the way to the left, then the LED should be off. If the potentiometer is all the way to the right, the LED should be at full brightness. And then I want a smooth transition from all the way off to fully bright. Does that make sense? I hope it does. And so kind of what the cool thing is here that we are going to be doing is you're not going to be having to input anything from the keyboard. You're not even going to have Bonnie running. If you save the program as main, when you just power this up, as soon as you power it up, then what is going to happen is you're going to be able to set the brightness of the LED through the little potentiometer. Does that make sense? I hope it does. Give me just a second here. I'm trying to get these things all configured. Okay, so when you do your homework assignment, make sure that you post your homework assignment to YouTube. Down in the description, leave a link over to your homework assignment, and then in your YouTube video, make sure that you link back to this video so that people will know where you are coming from. Okay, guys, hope you are enjoying taking these lessons as much as I am making them. If you're enjoying this, make sure that you give us a thumbs up, and also share these videos with other people, because most importantly, the world needs more people doing coding and fewer people sitting around watching silly cat videos. Paul McWhorter from TopTechBoy.com. I will talk to you guys later.